Hello there, this is Lana Tuckey with the lecture notes for section 4.3 of Math 131. So in this section we're going to be dealing with the graphs of exponential functions. What are exponential functions? What do they look like? How do they work with both a table and a graph? And what kind of relationships are we seeing? So let's begin with the definition. An exponential function is a function that's of the form f of x equals a times b to the x. A cannot be 0 because if a was 0, then the whole function would be 0 and you're talking about the x-axis, y equals 0. And b is a number that is greater than 0, but it cannot be 1 because if b was 1, again, you'd have a horizontal line. You wouldn't be going anywhere. That b is called the base. So this function that you're seeing right here, this is your new best friend. So in the first few chapters, we spent a lot of time with y equals mx plus b. That's a linear function. And from this chapter, we're going to be dealing with f of x equals a times b to the x. A and b are now our new important constants, where it was m and b before. All right, now let's look. For each exponential function, fill in the values and draw a graph using fractions. Okay, so let's see here. Let's bring up a calculator to help us with this. We could also use our heads just a little bit here. We can probably figure out some of these on our own. So for example, 0, 2 to the 0 power, well we just learned that in section 4.1, that's 1. 2 to the 1 power is 2. 2 to the 2, that's 4. 2 to the 3, that's 8. That's 2 times 2 times 2. 2 to the 4 is 16. And you can see as we work down this table, we're multiplying by 2, right? 2 to the negative 1, we learned in section 4.1, that's 1 over 2, right? There we go. And then 2 to the negative 2 would be 1 over 2 to the positive 2, which would be 1 over 4. And then 2 to the negative 3 would be 1 over 2 to the positive 3, which is 1 over 8, and so on. Okay? So, and of course we could use our calculator to help us with this just a little bit. It can't really help us too much with the fractions, but if I go y equals, let me go up and turn off that plot one. That's a scatter plot. I don't need a scatter plot. And I want to type 2 caret button. See that little guy? That's called the caret x, like that. Now the new calculators will make it look 2 to the x. It'll actually raise it as a superscript. The old calculators will actually have the little caret symbol in there, the 83s. All right, and then I go to the table. So I hit second graph, and then that's going to get me to the table. And I can see I was right about the 1, 2, 4, 8, and so on. And then these ones are a little bit harder to see, but 0.5 is a half, 0.25 is a quarter, and then you're in a little bit of trouble. That's why when I say to use fractions, you can use the calculator to help yourself, but you're going to have to know how to do this in order to find fractions for these numbers. All right, so now we're going to graph it. So let me pause you and I'll be right back with a graph. Basically, you just plot these points, right? So hold on. Poof, there it is, like magic. So here's 0, 1, that's the y-intercept right there. 1 goes to 2, 2 goes to 4, 3 goes to 8, and so on. And that's an exponential graph. Now notice it never actually touches this x-axis. We'll talk about that a little bit more in a second. But it's kind of skimming along the x-axis because these numbers are getting smaller and smaller, but they're not turning to 0. If I go back to the calculator, and you can see here, it's getting smaller and smaller for these numbers over here for the y, but they're not 0. Look, they're so small, they're scientific notation, right? So that's 0.00006, right? Very small, but not 0. Okay. So there's that graph. Now we're going to do it again with 3. Okay, well, 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, 33 is 27. For these ones, though, let's use the old trick of 3 to the negative 1, that's 1 over 3 to the 1. 3 to the negative 2 would be 1 over 3 squared, which is 1 over 9. 3 to the negative 3 is 1 over 3 cubed, which is 1 over 27. All right, now we're going to graph that graph. So I'll be right back with that graph. And there it is, like that. Okay? So you can see you have two lovely graphs. They're very similar, but this one on the bottom is growing a little bit faster. It's a little steeper than this one above. And that's going to lead us to the answers at the bottom of the page. One sec. There they are. Those are the questions. All right, so when the base b is greater than 1, which we had for these problems, this one here has a base of equal to 2. Matter of fact, let me make a note over here somewhere. Hold on. Note. There we go. We want to make a note that a is equal to 1 because, let me write it out, it's really 1 times 2, 1 times 2 to the x, because you don't really see a number in front. So that's 1, and then b is 2. That'll become a little bit more important to us in a sec, but that's the general idea. Okay? All right, so now, what about this one down here? Well, again, you don't see a number in front of the 3. So our base is 3, but our a is 1. So this is 1 times 3 to the x. Okay? So what are we learning here when the base b is greater than 1? Well, we can see that these functions are growing, right? They're going up. What else can we learn? The graph is increasing, right? That's the fancy way of saying going up, right? From left to right. We always read graphs from left to right, just like you read a line of English. The blank is a horizontal asymptote. Well, that's what I was talking about earlier. These functions are getting closer and closer to 0, but they're never touching. So the x-axis, right, is a horizontal asymptote. The domain is all possible x's. So inputs, as it were. That is negative infinity to infinity, aka all real numbers, right? That is your domain, right? Because the graph goes forever to the left. I can't put little arrows on this because of what I'm graphing in, the program I'm graphing in, but they're there, right? All real numbers from negative infinity to infinity, that's your domain, excuse me, from as far left as you can go to as far right as you can go. Now the range, not so much. The range, well, you never get to 0, right? Remember the table here. We're never getting to 0. No matter how hard we try, we're just getting smaller and smaller numbers. So our range is, let's see, 0 to infinity, right? We never quite get to 0 though, so he doesn't get a bracket. He gets a parentheses because you never get to actually reach or touch 0. You never touch that x-axis. You just kind of skim along it like a surfboard. All right, we're done with that page. Let's see about the next one. Oh, okay, same idea, but now we're going to be doing fractions. So let's see, a half to the 0 would be 1. A half to the 1 would be a half. And then a half to the 2 would be, let me show you can see, it's 1/2 squared, which would be 1 squared over 2 squared, right? Which is 1 over 4. Okay, the next one would be same idea, but it's cubed. So it's 1 cubed over 2 cubed, so that's an eighth. All right, what about to the negative 1? What happens when you take a half to the negative 1? Well, that's 1 to the negative 1 over 2 to the negative 1, but we learned in section 4.1 that those flip. It becomes 2 to the positive 1 up here and 1 to the positive 1 down here, which we all know is 2. All right, then I can do that same process again. Hold on. There we go. What about if he did negative 2? 2 to the negative 2, or excuse me, a half to the negative 2. That'd be 1 to the negative 2 over 2 to the negative 2. That's 2 to the 2 over 1 to the 2, which is 4. And hopefully you can see there's a pattern here, right? So if it was 3, it'd be 1 to the negative 3 over 2 to the negative 3. So they flip-flop, and it becomes 8. And then you can see, hopefully, you went 1, 2, 4, 8. This one's going to be 16. oops, 2 to the 4, there we go, which is 16. All right, so now we have to graph all of that. All right, hold tight. There it is. There's the graph. So you can see there's 0, 1, there's negative 1, 2, and so on. And I just put a note in here that A is 1 and B is a half, right? I can't make it red because of the program I'm typing in, but you get the general idea, right? So it's 1 times a half to the x. All right, now we're going to do it all again, but with a third. Okay, but it's the same concept, right? So it's going to be 2 or 1/2, excuse me, 1/3 to the 0 is 1. 1/3 to the 1 will be a third. And then I'm just going to do one of these, and then you'll get the idea. This will be 1/3 squared, so that's 1/3 squared, which is 1/9, and so on. So let me fill out the rest of this table. One sec. Okay, there's the 1/3 to the third. That's 1 to the third over 3 to the third. That's 1/27. All right, let me show you one of the negative ones because they're a little funky. So let's do 1/3 to the negative 1. That's really 1 to the negative 1 over 3 to the negative 1, which you flip-flop them, and that's 3 to the 1 over 1 to the 1, which is 3. All right, now for a third to the negative 2, that's 1 to the negative 2 over 3 to the negative 2, and then you flip-flop them. 3 positive 2 over 1 to the positive 2, so that's 9. And then let's do the negative 3 one. This is 3, 3, 3. So then you flip-flop them and turn the variables, the powers positive, and so that's 27. All right, so now I'm going to graph that. There we go. So for this problem, A was 1, again, because you don't see a number in front. So it's 1 times a third to the x. And there's the graph of it right there. So these are both decreasing, right? So they're exponential decay. And what you could notice is that for both of these, B was between 0 and 1. B was a fraction, smaller than 1, bigger than 0. But again, the x-axis is a horizontal asymptote. Let me prove that to you. I'm just going to put in the half one to my calculator. So we go to y equals, clear this, and do 1/2. There are other ways to do this, but I'm going to do it this way. 1/2, oopsie, parentheses, 1 divided by 2. There we go. Close parentheses to the, so caret button, x. All right, so let me go back to the table, and you can see, if I scroll down, I'll find the points that we had in our table. Right, so there's 16, there's 24, or excuse me, 2 and 4 and 1.5. There's a quarter right there, there's 1/8 right there, and so on. But you can see it's never getting to 0 and never gets there. It just keeps skimming along and getting smaller and smaller decimal places. So when you graph it, it never actually touches the x-axis. Oops, there's a graph. I had to press zoom standard. I had a weird window. So there it is. See, it's skimming along. It just kind of keeps going and going on there. And that's what our graph is showing. It keeps going along on there. You know, I like that color so much, I actually went back and changed these graphs so they're blue. So that's prettier. So there we go. So you can see it more clearly. There it is surfing along. So the x-axis is a horizontal asymptote. The domain is just like it was before. It's negative infinity to positive infinity. It's all real numbers. That graph never stops. It just keeps going left to right. Okay? But the range is also what it was before. The range is from 0 to infinity. Hold on. There we go. I got it in there. 0 to infinity. Because you never hit 0, you don't get to put a bracket on 0. It just kind of skims along 0, just like the other ones. All right, so we're done with looking at the basic graphs for when b is greater than 1, that's these ones, and b is a fraction between 0 and 1. Now notice all of these had a being positive, positive 1 as a matter of fact. So we'll talk about that and what happens when we start changing that stuff around on the next page. So I'll see you then for that video.